In this lesson, we will discuss a method to integrate certain functions by an appropriate trigonometric functions. Now, some of these integrals can be actually made much simpler using this trigonometric substitution. That means you must be familiar with some of the trigonometric identities that we are going to use here. And one such trigonometric identity is 1 minus sine squared theta equal to cos squared theta, or cos squared theta equal to 1 minus sine squared theta. The second one is secant squared theta minus 1 equal to tan squared theta. And the third one is 1 plus tan squared theta equal to secant squared theta. You must be able to use these three identities in doing our substitution. So you must be very thorough with these. And trigonometric substitution is useful for integrating expressions of some basic forms like square root a squared minus u squared. Now, you see, when you have a square root quantity, our aim is to get that square root out of the way so that we can simplify it and make it in a form we can integrate it. For example, if square root of a squared minus u squared. Now, which of these three forms will actually simplify this? Now, let us say u equal to a sine theta. Now, I'm going to write that down for you. Let's make a substitution like u equal to a sine theta. Now, why did I decide to do that? You have u equal to a sine theta. Now, what is du equal to? Du equal to a cos theta. Is that right? So, when you replace your u by a sine theta, what will our u squared be? The quantity now becomes a squared minus u squared is a squared sine squared theta. Now, at the moment, we are not going to look at du. We will simply simplify the square root quantity. Now, this can be written as square root of a squared can be factored out, a squared times 1 minus sine squared theta. Now, look at the way a simple substitution like u equal to a sine theta brought this quantity 1 minus sine squared theta. So this 1 minus sine squared theta can now be replaced by cos squared theta, and if you notice, a squared times cos squared theta, that will be square root a squared times cos squared theta, and that will be a cos theta. It became a very simple form which can be integrated. So, whenever you have this form a squared minus u squared, what is the substitution that you will make? You will make the substitution u equal to a sine theta. Alright, let's look at another basic form. Alright, now the next basic form is square root of u squared minus a squared. Now tell me, in this case, in order to take that square root off, what kind of substitution will you do? What will you call u equal to in these three forms? Well, it must be u equal to secant theta. If you call u equal to a secant theta, that a has to be taken into consideration. If u equal to a secant theta, then you have u squared equal to a squared secant squared theta. Is that right? And you can factor out that a, and you can come up with something like this. And the third one is square root of a squared plus u squared. And you can see obviously that will be of the form u equal to a tan theta. Is that right? Alright, now we will see how these forms are replaced by an appropriate trigonometric function or identity in order to make these integrals simpler. Now, in the expression a squared minus u squared, substitute u equal to a sine theta. I just did that for you. That gives me square root a squared minus u squared equal to square root a squared minus u squared is a squared sine squared theta, and factor out the a squared and replace 1 minus sine squared theta by cos squared theta. That give you a cos theta. That became very simple. And what did we say we substitute here? Square root u squared minus a squared. We substitute u equal to a secant theta. What will that become? That will be square root of u squared become a squared secant squared theta. And factor out the a squared. That gives you a squared times secant squared theta minus 1. What is secant squared theta minus 1? Equal to tan squared theta. So that will be square root a squared tan squared theta becomes a tan theta. And finally, in the expression square root a squared plus u squared, we substitute u equal to a tan theta. When u equal to a tan theta, u squared will be a squared tan squared theta. So that becomes square root of a squared plus a squared tan squared theta, and a squared is factored out, and then replace 1 plus tan squared theta equal to secant squared theta. So that will be square root a squared secant squared theta, and that is a secant theta. So by doing this appropriate trigonometric substitution, we made this sort of complicated quantity into a manageable terms that can be integrated. Alright, now let's summarize this. Form of the expression and what is the substitution that you will make. And you need to learn this and have to be very careful in your substitution. The form of the expression square root a squared minus u squared. What is the substitution we make? U equal to a sine theta. Alright, the second expression square root u squared minus a squared. What is the substitution that you will make? U equal to a secant theta. And finally, square root a squared plus u squared. The substitution is u equal to a tan theta. So keep this table with you and refer to this whenever you use this method of trigonometric substitution. Alright, let's